Hello. So in this video today I'll explain what is VM, which is virtual machine, where is it used, what are the advantages and disadvantages of it. Okay. So as the name says, virtual machine, it is not a physical server or machine. It is a virtual thing. A virtual machine is a software based computer that runs its own operating system on shared physical hardware. It runs inside another machine. It shares the CPU, memory, and disk of the host machine, and it has its own operating system Linux, Windows, Mac OS. Suppose one physical server has first VM which has a Linux server, second VM which has a Windows server, a third VM which is a database server. So these all are running independently. So why is VM needed? That is the second question. What is the need of it? Why can't we use the physical server only? So the first need is it gives the isolation. So each VM has its own operating system. As we have seen on one physical server, there can be Linux, Windows, and database server, and which all these three are isolated. So isolation is one of the important point why we need VM. If one VM, and also it is used for safer purpose also, if one VM crashes, others are safe. If Linux server crashes, Windows server, database server, and physical server is safe. Second is better hardware utilization. Suppose if there is only one physical server and there is only one application, and we are using another physical server for second application, then all the disk, CPU, memory spaces which are left are unutilized. Whereas here, if we add one VM or other VM, then space is utilized. So the second point is better hardware utilization. Earlier we only had one server, one application. Now one server can have multiple VMs, multiple application. Third point is easy scaling. VMs are can be created or deleted in minutes, and it is used in heavily cloud environments like AWS, Azure, where it is as a EC2 instance. Another point is security. Here we have OS level isolation, so it is safer than running everything on one OS. Suppose we want, for one application we want Java version to be some 1.1, and for other application we want it to be 1.2. So then we can't have both version in the single OS. So VM helps us here. So it is also OS level isolation. Another point is different operating system on same hardware. So as we have seen, Linux plus Windows on the same server can be there. So VM allows isolation, efficient resource usage or hardware usage, and the flexibility in running multiple OS on the same hardware. So another question is, where is VM needed? So it is needed at many places in current scenarios. So first is cloud computing, and it is most important in AWS, Azure, and GCP. We use it everywhere. So EC2 instance in AWS is a virtual machine. Every cloud server we create is a VM. Almost all cloud workloads start with VMs. Another use it is for it is production application like backend services, database, and legacy applications. Another is Kubernetes node. Kubernetes node usually runs on VMs like EC2, Azure, VM, GCE. Each VM acts as a worker node. Another usage is for testing and development. Test apps on different OS versions, safe experimentation. And last one is security and compliance for sensitive workloads, regulated industries like banking, healthcare. It is used. So, to summarize, a virtual machine is a software based computer that runs its own operating system on a shared physical hardware. VMs are needed for isolation, better hardware utilization, security, and ability to run the operating system on the same server. They are widely used in cloud computing, production workloads, Kubernetes cluster, testing environments, and secure sensitive applications. But as everything has two sides, there are also disadvantages of virtual machines too. First is its heavyweight. Each VM runs a whole operating system in it as a Linux, Windows, or Mac application. So it is very heavyweight and it consumes more CPU, RAM, and disks. The second disadvantage is a slow startup time. So it is a like a OS machine on its own, right? So it also takes VM boot time as it takes for new our physical server to start. So VM boot time is of minutes, not seconds, and not ideal for fast scaling. If we want to scale something in seconds, then it is not ideal. Another disadvantage is low performance than containers. Compared to containers, extra OS layer causes overhead. I'll explain containers in one of the next videos. Yeah, so we can see the difference between VM and containers there also. Another disadvantage is resource wastage. Unused CPU memory is still reserved. Suppose if we have installed one Windows VM in our physical server and there are some unused space, then it is still reserved, so it is less efficient than containers. And last disadvantage is complex management at scale. For OS patching or security updates or monitoring many VMs, so we can't monitor many VMs that much efficiently. OS patching and security upgrades, we need to do it in each VM separately, so that is a difficult thing. So, as we have seen the advantages and disadvantages of VMs, what we can say is when we need to use the VMs and when we do not. So, when we use VMs, so when we need a strong isolation, when we want to run a different OS, when we have a legacy application, or security and compliance is more important, then we can use the VMs. And when to use containers, when we need fast scaling, microservices, or in high resource efficiently, we can use the containers. So let's see VM versus container, the main difference. So a VM virtualizes the hardware and runs a full operating system, whereas a container virtualizes the operating system and runs only the application plus dependencies. It does not run the full operating system. And let's see the VM and container architecture difference. So in VM architecture, there is a host operating system, hypervisor, guest operating system, and application. Whereas in container, there is a host OS, container and runtime, Docker or containerd, and application. Containers share the host operating system kernel. So we'll see the container later and discuss these points later. Let's just focus on VM here. So one question which I had and I wanted to explain. So why can't we just run all application in one OS if everything is Linux? Suppose our application has everything on Linux, then we can run everything on that physical server only. We don't need, do we need another OS? So these are the problems we can have if we run everything all application on one. So first is application conflict. Different apps need, so if database has a different apps and the application has different need, so different library versions, different runtime version, like app A needs Java 8 and app B needs Java 17. So on one OS installing Java 17 may break app A. VM solves this by giving each app its own OS environment. Second problem is if one app crashes, then it can affect all. If all app runs on the one OS, memory leak, disk full, or kernel panic, this issues crashes all the application. So we can't have isolation and everything is failed. So entire server goes down. All applications are affected. With VMs, it only that VM is impacted, not all. Third problem we can have is a security risk. If one app is compromised, attackers get access to the host operating system and they can access all apps. With VMs, OS level isolation is there, so it's much harder to break out the all VMs. It can access one but not all. Another problem is scaling nightmare. If one app needs more CPU, we need to scale the entire machine. Others app waste the resources. With VM, we can scale only one VM. If we have given VM of 2 CPU, then we can easily scale it to give the 4 CPUs. For a single application, we can't divide that way. So, to summarize, running everything on one operating system creates dependency conflicts, security risk, and operational instability, where VM solve this by isolating workloads. So as we seen, VM is a logical physical machine. So next question is, how is it used in EC2? Like for that, where is the host OS? If we see like VM use, we have seen that on physical server there is this VM, right? So for EC2 and all cloud VMs, where is the host server? So in cloud like AWS, where it is VM is used in EC2, so we never see the host operating system. But what actually happens, physical server is a AWS data center, like host operating system and hypervisor, it is managed by AWS. We have our EC2 instance and we have our own operating system, which system we are using. So the OS exists, but it is owned by AWS. We don't need to manage it and we don't see it. So EC2 is equal to VM in a simple truth. So EC2 instance is a VM. So our Linux inside EC2 is a guest operating system. And AWS manages physical hardware, host operating system, and a hypervisor. So to summarize, although applications can technically run on the same operating system in production, this causes dependency conflicts, security risk, and failure blast radius. So virtual machines provide a OS level isolation similar to physical server, but with much better flexibility and cost efficiency. In cloud environments like EC2, the host operating system and hypervisors are managed by the provider, and we interact only with the guest OS inside the VM. So Kubernetes also nodes typically run inside these VMs. And one last question is, how is scaling done for VMs? So scaling VMs means infrastructure scaling, not application level scaling like Kubernetes. So there is a vertical scaling and there is a horizontal scaling. To in so vertical scaling means increase resources of the same VM. For example, if one VM has a CPU 2 and RAM memory 4 GB, and we want to increase CPU to 4 and memory to RAM 8 GB, then it is used. So when is it used? Vertical scaling. So database needs more memory or in legacy apps. And then second is horizontal scaling. So it is adding more VMs. For example, if we have one VM and then we want to increase to 3 VMs, like load balancer in front. And when is it used? So it is used in web application for high availability. Like examples are auto scaling the group launches, a new EC2, or load balancer distributes the traffic. So this is all about the VMs. Thank you. If you like the video, please do like and subscribe.